All right, here's, oopsie, sorry about that. Lost it already. All right, here's a problem that was on my math lab that requires you to rationalize a denominator that is not as easy as maybe some that we've seen so far. So first of all, the tangent of alpha minus beta, again, you can just kind of look up the formula for that. So that's not anything that you have to have memorized or anything like that. So that would be what? The tangent of alpha minus beta is what? The tangent of alpha minus the tangent of beta all over 1 plus tangent of alpha times tangent of beta. So what we need is tangents, and obviously we have one here, which is awesome. We have that tangent, and I believe actually that that's a negative, obviously, if we're in quadrant 2. Has to be negative. So we do need the tangent for this guy. So I am going to draw my little circle. I'm in quadrant 1, so here's my bow tie. So ka toa, so adjacent over hypotenuse. So there's 5, there's 6. And I'm going to do Pythagorean theorem to figure out that missing side. So 36 minus 25 is 11. So that guy is square root 11. And so what do I want from this? I want tangent of, what is that, beta right there? Okay, so tangent of beta, so ka toa, so opposite over adjacent. And again, everything's positive there. And then this one we don't need to draw. We could, but they already gave it to us, so we're not going to waste our time with that. So at this point, it's just subbing in these ratios where it says tangent of alpha or beta. So tangent of alpha is a negative 4/3 minus the tangent of the other guy, which is this one, all over 1 plus the product of those two. So negative 4/3 times, what is that, square root 11 all over 5. All right, so now we're dealing with fractions. So when you add fractions, you obviously need a common denominator. So this is 15. I don't know that it actually changed colors there. So 15, so I'm going to multiply this guy by 5 and multiply this guy by 5 and times 3 times 3. So that gives me what? Negative 20 over 15 minus 3 radical 11 15. Over here, I need to multiply, but I also eventually am going to need a common denominator. So I'm going to go ahead and change this one. 1 is 1 over 1. So I could make that 15 over 15, 8 over 8, anything I want. So 15 over 15. And then this is negative 4 square root 11 all over 15. And remember, with radicals, you can multiply a radical times a radical, but this is a whole number, so it just acts as a coefficient. It can get multiplied by the 1 there, but it can't impact the radical. All right, so now we have common denominator, so I can make this a single fraction and make that a single fraction. So negative 20 minus 3 radical 11 all over 15, and my other one is 15 minus 4 radical 11 all over 15. So I have complex fractions, and so I'm messing with those. And so at this point, I have a single fraction over a single fraction. So finally, I can multiply by the reciprocal. So I'm going to take negative 20 minus 3 radical 11 all over 15. And then let's see, what do we have here? And then I have 15 minus 4 radical 11 all over 15 here. Why did I just recopy that? I have no idea. I'm sorry about that. Too much NCAA basketball going around, I guess. All right, let me try again. All right, so I'm going to have this guy. And then I'm going to multiply by the reciprocal. All right, these are factors, so they cancel. These are factors as chunks. So if I wanted to cancel anything, I'd have to cancel it as a chunk or be able to take out a greatest common factor of both those and greatest common factor. So just because there's a 5 in common, that doesn't matter because these are not factors. Those are add-ins. So I can't factor out a 5 from both of those, and I can't factor out a 5 from those. So they're kind of, I'm stuck with them as is. So negative 20 minus 3 radical 11 all over 15 minus 4 radical 11. Now the problem here is our denominator has a radical, and if I multiply by the square root of 11, that's not going to fix it because I'm going to distribute it over here. And so what we use is conjugates. Conjugates kind of go back, a little bit to like a binomial times a binomial. So when you think of, say, like x minus 8, x plus 8, when you do that math, your outside inside cancels and you just get x squared minus 64. You get the difference of two squares. So we're going to kind of use that idea. so that we want our outside inside to go away. So we're going to use the conjugate of this, which means it looks exactly the same. So 15 and 4 radical 11, except instead of minus, we're going to change it to plus. So we kind of get that x minus 8, x plus 8 going on, except it's 15 minus 4 radical 11 and 15 plus 4 radical 11. And again, I have to do the same to the numerator as I do to the denominator, because in a sense, I'm just multiplying by 1. So you use what we call the conjugate. It's identical to this, except instead of minus, it has plus. If this was plus, I'd use minus. All right, so now you're just going to do FOIL to multiply this guy out. So first you have a negative 300. Outside you get a negative 80 radical 11. Inside you get a negative 45 radical 11. And last you get a negative 12. And then square root of 11, or square root of 11 times square root of 11 is the square root of 121, which is 11. Again, a square root of 11 times square root of 11 is the square root of 11 squared, so the squarine and the square rooting cancel. All right, in my denominator, again, I'm going to do first, which is 225. Now notice what happens here. Your outside and inside are going to cancel. This is going to be a negative 60 radical 11. This is going to be a positive 60 radical 11. Yeah, those are going to be just like out here. Outside, inside are going to cancel because they're opposites. So I only have first and I have last, which is a negative 16. And again, square root of 11 times square root of 11 is an 11. It would be the square root of 121, which is 11, or it's square root of 11 squared. Either way. All right, so now I can simplify. This is what? Negative 132. So minus 132. And this is what? Minus 176. All right, so let's see what I have here. I have 300 and, let's see, negative 132. So what is it? Negative 432. And that's a 4, not a very good 4. Let me just try that again. Sorry about that. All right, so negative 432. Maybe I didn't do any better this time. And then negative 80, and that is negative what? 125. Square root of 11 all over, and then if I subtract those, let's see, that's 24, 25, 49. All right, and then if these had, like, say, both a 7 in common where I could factor it out and factor out a 7 from this, I could do that, but 125 is just 5 times 5 times 5. There's no factor of 7 in there. So this is my final answer. Now, if you really, really want to check your answer, which I highly recommend, I would go back to the beginning and type in these original fractions. So like a negative 4/3 minus square root of 11 and hit enter on your calculator. And then 1 plus that, enter on your calculator and divide and see what decimal you get. And then I would compare that to this. So type in negative 432 minus 125 radical 11, enter, divide by 49. And if the decimal you get up here with these ratios, and again, you have to be a little careful with nested parentheses if you decide to do it all in one step, should match this guy.